This is part 2 of your Chapter P notes. So now let's put together everything we've been talking about so far. We have the square root of 27, so we can break down 27 into 3 times 9, 3 times 3 times 3. This is a square root, so put them in groups of 2. 1 survives on the outside. 1 has to stay on the inside. Now we do the same thing with the 8. That's 2 times 4, 2 times 2 times 2. Put them in groups of 2. 1 survives, and 1 has to stay on the inside. Now we just did 32 on the previous page, and we got 2 times 2 times 2 5 times. This is a square root, so we have to put them in groups of 2. That means 1 from each of these makes it out, but this one stays inside. So this gives us 4 square roots of 2. Now to add radicals, you have to make sure that the radical parts are the same. These are actually like terms because the radical parts are the same. So the 3 square root of 3 stays there, but negative 2 square root of 2 plus 4 square root of 2 would give us a positive 2 square root of 2. We got that because negative 2 plus 4 is positive 2. So let's look at this next one. We have the square root of 12 x cubed y to the 9th z to the 0. Well, first of all, what is z to the 0 power? It's 1. Remember, anything to the 0 power is 1. And what is the square root of 1? It's just 1. So when we have this right here, we don't even need it anymore. It's just 1. So let's break down 12. Let's say 2 times 6, 2 times 2 times 3. The 2's come out, only 1 survives, and the 3 stays inside. So we're going to have a 2 and a 3 here. Then we have 3 x's, and we have 9 y's. Well, these two get grouped, and then we need to put these in groups of 2. So we have 1x on the outside, 1x on the inside. We have 1, 2, 3, 4 y's on the outside, and 1 y on the inside. This is the simplified version of that particular problem. So what about this one? We have x to the 2/3 times x to the 4/3. Remember, when you multiply like bases, you add their exponents. So you get x to the 2/3 plus 4/3. Well, these fractions already have common denominators, so you get x to the 2 plus 4 will be 6, 6/3. But 6/3 reduces to 2. Remember, whenever you have a product raised to a power, you raise each of them to that power. And when you have a power to a power, you multiply the powers. So we're going to have a to the 3/2 cubed, b to the 2/3 cubed, all over a squared cubed. We have to raise this to that power as well. Let's come up here. So a to the 3/2 cubed, multiply 3/2 and 3, and you get a to the 9/2. b to the 2/3 cubed, 2/3 times 3 would just be 2. A squared cubed would be a to the 6th. Well, now we have a to the 9/2 over a to the 6th. We need to subtract these exponents. 9/2 minus 6 over 1. We need common denominators. It's going to be 2. 1 times 2 is 2, so 6 times 2 is 12. 9 minus 12 would be negative 3. So we're going to have a to the negative 3/2 b squared. But what if we don't want to keep a negative exponent? Remember, negative exponent means put it on the other side of the fraction. So we're going to end up with b squared all over a to the 3/2. We will talk more about a problem like this later, but we'll leave it as that for now. Okay, now we're going to rationalize the denominator. That's what I was talking about on the previous slide, but we will talk about that more later. Whenever you have a fraction, to make it completely simplified, you're not supposed to leave a square root or cube root, any radical in the denominator. Well, in this case, to rationalize this denominator, you just need another 3. This is a square root, right? 3 is prime. To get rid of that 3 out from under that radical, you have to have another one so that it can escape prison. So you multiply it by a very special 1, and that 1 is the square root of 3 over the square root of 3. Well, what happens? 1 times the square root of 3 is the square root of 3. Square root of 3 times the square root of 3 would actually look like this. And you see how you can put them both in a group? They both get to come out, but only one survives. So you get the square root of 3 over 3. You have now rationalized the denominator. So what about one like this? Over here, this was a square root, so they had to be in a group of 2. Here, to get this 3 out from under the radical, it needs to be in a group of 3. That means you need 2 more 3's to get that 3 out of there, right? And if you have 3 times 3, you really have 9. Alright, so what we're going to do is multiply this, not equals, we're going to multiply this by the cube root of 9. Okay, we have 4 times the cube root of 9 over the cube root of this 3 and this 9, but this 9 is 3 times 3. Do you see how now we have a group of 3? Now they all get to come out, but only one survives. So we have 4 cube root of 9 all over 3. So what if instead of a 3, we have a 9 here? What we have right now is 4 over the cube root of 3 times 3. But for these 3's to escape, they need another partner. They need one more 3. So what we do is multiply this by the cube root of 3 over the cube root of 3. We give it what it needs. But as long as you multiply the numerator and the denominator by that, it's legal. No problem. So in the numerator, we have 4 cube root of 3 all over. I'm going to write all of that out so you can see what it is. So it would look something like that. Now they're all 3 in a group and 1 comes out. So we have 4 cube root of 3 all over 3.